Complex numbers. So any number that can be represented of the form a plus b is called a complex number, where a is called the real part and b is called the imaginary part of the complex number, and the I is called the imaginary unit of the complex number. So if there is a complex number z equal to 6 plus 5i, then 5 is called the imaginary part and of the complex number, and 6 is called the real part of the complex number, and I is called the imaginary unit of the complex number. So then we come to the operations of complex numbers. So the first operation is the addition of two complex numbers. Suppose there are two complex numbers z1 and z2, and another thing, complex numbers are generally represented by z. So if there are two complex numbers z1 equal to a plus ib and another complex number z2 equal to c plus id, then the z1 plus z2, the sum, will be represented as a plus c plus b plus d into I. That means the real part and the imaginary part gets added respectively. Now the properties of the sum are: the sum is always a complex number, means when we add two complex number, the resultant will always be a complex number, it cannot be a real number, and it always obeys commutative law, that is z1 plus z2 equal to z2 plus z1. It always obeys associative law, that is z1 plus z2 in bracket plus z3. We can write this as z1 plus within bracket z2 plus z3. Now additive identity. Now with for every complex number there exists another complex number represented as 0 plus I, or can be represented only with as 0, for which z plus 0 equal to z, means on summation with that number will give the original number itself. And then we have additive inverse. Additive inverse states that for every complex number z equal to a plus iv, there exists another complex number minus z, which is represented as minus a plus I into minus b, such that z plus minus z equal to 0. And this minus z is called the additive inverse of z, means on which the complex number on adding which with the original number gives 0. It can be considered as the additive inverse of the original number. Then we come to difference between two complex numbers. Suppose there are two complex numbers z1 that is equal to a plus ib, z2 equal to c plus id. Then z1 minus z2 can be represented as a minus c plus I into b minus d, means the real part and the imaginary part get subtracted respectively. Just like in case of addition it got added, it will get subtracted in case of subtraction. Now multiplication of two complex number. So let us consider two complex numbers z1 equal to a plus ib and z2 equal to c plus id. Then the product z1 plus z2 will be equal to a plus ib into c plus id. That is on multiplying we get ac plus adi plus bci plus bd square. That is on further, if we take the real portion, that is AC minus BD. Now why this is minus BD? Because it is plus BD square, and I square can be written as minus 1. This is fixed, this value cannot be changed, this is defined, this is a defined value. So this becomes BD into minus 1, so AC minus BD, and if we take I common, then I into AD plus BC. This is the product. when we come to the properties of multiplication of complex number, so the properties are the product will always be a complex number. Then it obeys commutative law, that is we can write z1 into z2 equal to z2 into z1. It obeys associative law, that is if we within bracket if we write z1 into z2 and outside the bracket into z3, it can be also written as z1 into within bracket z2 into z3. Then multiplicative identity, so if there exists an complex number 1 plus 0i, also represented as I, as the imaginary part of that complex number is 0, so only the real part is remaining, so we can write it as 1, such that z into, on multiplying with the original number, that is z into 1 equal to z for every complex number z. Then multiplicative inverse, for every non-zero complex number z equal to a plus ib, we have another complex number a square plus a by b square plus I into minus b divided by a square plus b square. Now this comes where from this number comes from. Let us consider z equal to a plus iv. So z inverse will be 1 by a plus iv. So we can, if we rationalize it, we can write it as a minus ib divided by a minus ib. So it can be written as a minus ib divided by a square minus ib square. That can be written as a minus ib divided by a square plus b square. This is b plus b square because this was minus b square into I square. So I square, the value of I square is minus 1, so minus 1 into b square plus 1, plus b square. So we get a plus a minus ib divided by a square plus b square, this which can be written also as a square. If we split it, it can be also written as a square divided by a square plus b square plus I into minus b divided by a square plus b square, which is of this form. Now it also obeys distributive law, means if z, it is given z1 into z2 plus z3, it can be also be written as z1 into z2 plus z1 into z3. Now we come to the division of complex number. So if there are two complex numbers z1 and z2, when we divide z1 divided by z2, it is just the product of one number with the inverse of other. Suppose it is z1 by z2 here, so it will be z1 into 1 by z2. So multiplicative inverse means we have learned in the previous how to take out the multiplicative inverse. So we can take the multiplicative inverse of z2 and just multiply it with the z1, then we will get the division result of two complex number. Now power of I. Now in the previously we know that I have said that I square equal to I square can be also be represented as minus 1. So it is same like that. I square is equal to minus 1. It is fixed. This value is defined. And next we come to I cube. Then it is I square into I, which is minus 1 into I, that is minus I. And then we come to I to the power 4, which is I square into I square, that is equal to minus 1 into minus 1, that is equal to 1. Now remember one thing, that for if the power of I is even, then the result will always be 1 or minus 1, and if the power is multiple of 4, then the value will be always be 1, and otherwise if it is even and not multiple of 4, that will be minus 1, means I to the power 4 equal to 1, and if it is I to the power 6 equal, that will be equal to minus 1. you can check also, that is I to the power 4 into I square, that is I to the power 4 is 1, we already know, so 1 into minus 1, that is minus 1, and for every odd power it will be always be minus I or positive I. Then we come to modulus. For consider a complex number z equal to a plus ib, then mod z equal to root over a square plus b square, means the modulus can be written as mod z equal to root over a square plus b square. Now then we come to conjugate. Suppose an complex number z equal to a plus ib, then the conjugate can be written in the form a minus ib. Now we have seen that multiplicative inverse is just the opposite of it, means 1 by that number. So if we consider a number z equal to a plus ib, then the multiplicative inverse becomes a by a plus ib, 1 by a plus ib. Then we get a minus ib divided by a square plus b square, which is actually the conjugate divided by its modulus square. So this is also one property that we can get. Now there are more properties. Suppose the modulus of product of two complex numbers z1 and z2 can be written as modulus of z1 into modulus of z2. These two are separate. And similarly in the case of division, the modulus of z1 divided by z2 can be written as modulus of z1 divided by modulus of z2. And same in the case of multiplication, addition or subtraction. And this, in case of conjugate, it also follows the same rule, that is conjugate of z1 by z2 can be written as conjugate of z1 divided by conjugate of z2. And previously I told one thing wrong, that is I said that all the I containing odd number power is minus I, but it can be also plus I. So if it is next to the multiple of 4, suppose I to the power 4 equal to 1, then if it is I to the power 5, then it will be positive I, and if it is before the multiple of 4, just before the multiple of 4, suppose I to the power 3, then it will be minus I. Sorry for the misinformation.